In this lesson today, we're going to talk about composite functions and replacement sets. So let's go ahead and start ourselves off with the idea of a replacement set. So here I have an example where it says determine the solution set given the replacement set. And you'll also see that I am given the function f of x equals negative 3x minus 5. So in order to find the solution set, I am always going to be given something called the replacement set. The word replace means to take something and replace something else with it. So in our case, what we're going to do is we're going to replace each of the x values into the function to see if we get the proper y value. So let's go ahead and test this replacement set. All right, I'm going to use the first coordinate here, which is negative 6, 13. I'm actually going to write it right here, negative 6, 13, just so I know that that's the point that I'm using. And I'm going to go ahead and I'm going to substitute my x and y values in. Remember, if I have f of x equals negative 3x minus 5, don't forget that my y value is going to represent f of x. So I want 13 equals negative 3 times negative 6 minus 5. Okay, I'm going to go ahead and simply simplify this out. It looks like I have 18 minus 5. You can see that 18 minus 5 does indeed equal 13. Since I get the left side equaling the right and my x value, when I substitute that in, it actually equals my y value. This right here, this coordinate is part of my solution set. So I'm going to go ahead and write that down here. All right, you'll also notice that I have 3 other coordinates to test. So let's go ahead and let's test the coordinate negative 4, negative 7. All right. So if I'm going to substitute f of x, I'm going to say negative 7 equals negative 3 times negative 4 minus 5. That is going to give me 12 minus 5. And that's going to give me negative 7 is equal to 7. You can see that negative 7 does not equal 7. And therefore, this coordinate is not part of my solution set. Although it is part of my replacement set, it's not part of my solution set. All right, let's test one more here. 0 and negative 5. So I'm going to say negative 5 is equal to negative 3 times 0 minus 5. Well, that's going to give me negative 5 equals 0 minus 5, which does indeed, negative 5 does equal negative 5. And therefore, this coordinate is also part of my solution set. And I'm going to go ahead and test my last one. I always have to test all of the coordinates that I'm given in my replacement set. I'm going to say negative 8 is equal to negative 3 times 1 minus 5. And they do indeed match up with each other. And therefore, 1 negative 8 is also part of my solution set. Now, your solution set can contain, one solution, 2 solutions, all of the solutions, and sometimes not even any of them. So you always want to be sure to check each and every one of them. Okay, now let's start talking about this idea of composite functions. Now, we've kind of talked about this idea of function notation, and now I'm given a bunch of equations or functions, and I have f of x, h of x, g of x, and k of x. And what I want to do is I want to use the given variables and solve the composite functions. So the first one says g of negative 4. That's how you say that, g of negative 4. The way I want to solve this composite function is I want to take that number that's inside the parentheses. Remember, that's basically the function g of x, right? So this negative 4 is being represented by my x. So what I want to do is I want to take my g of x function and I want to substitute negative 4 in for x. So I'm going to say negative 3 times negative 4 plus 5. And I got that function right up here. That's my g of x function. So now that's going to be 12 plus 5, which is going to evaluate to 17. Therefore, g of negative 4 is equal to 17. Okay, let's try another one. I'm going to kind of build myself up here. So let's do g of h of 2. We always start on the inside and work our way out. So let's go ahead and work with our h function, and let's substitute 2 into my h function. So if I were to say h of 2, that would be 4 times 2, right up here. And that would give me 8. So in here, this area here, I have 8. So really what I want to know is, what is g of 8 now? I'm going to go now and use my g function. So I'm going to say negative 3. I'm going to substitute my 8 in for x. And I'm going to add 5. So you can see here that it's simply just, plugging numbers in. So I'm going to have my negative 24 plus 5. And that's going to give me g of 8 is equal to negative 19. So really, the whole thing all put together, I want to say g of h of 2 is equal to negative 19. That's my final answer. All right, let's keep doing some more of these. Let's do h of f of x. Again, I always do my inside first, and it looks like my f of x is just equal to 2. So really what I want to know is, what is h of 2? Okay, now I'm going to go ahead and substitute my 2 in for my h function, which is going to be 4 times 2. So therefore, h of f of x is equal to 8. All right, k of g of x. I'm going to work with my g of x first. And I can see that my g of x is going to be negative 3x plus 5. I'm going to put that right into my k function. Now careful here. Watch how I do this. I'm going to say, here's my k function. Actually, I'm going to write it down so you can see it. There's my k function. I'm going to substitute my g of x into that. And again, you're going to put it right where the variable is. So negative 6. And then I'm going to say plus my g, which is going to be negative 3x plus 5. That's going to be my x value. So then if I take that whole thing and simply simplify it, I'm going to get negative 6 plus 5 is going to give me a negative 1. And then if I add this negative 3, it's going to give me minus 3x. So therefore, k of g of x is equal to negative 1 minus 3x. Let's try some more of these. Okay, now I have some new functions to work with. And now I'm going to be adding and subtracting given the functions that I have. So I might need to do these in multiple steps. So the first thing I have, let me go ahead and move my little cursor here. And I'm actually going to change the size of my pen to make it a little bit thinner so you guys can see. Okay. All right, so b of a of x. So I'm going to go ahead and work with this little piece first, a of x. I can see that a of x is equal to negative 4. So really what I want to know is, what is b of negative 4? Well, b of negative 4 is, if I put my negative 4 into the b function, I want to put it into negative x squared. So I'm going to say negative parentheses negative 4 squared. And I'm going to simplify that out. Order of operations says negative 4 squared is 16 times negative 1 is going to give me negative 16. So this first section here, I'm just going to kind of draw a little line. That first little chunk here, the answer is negative 16. But now let's go ahead and do the other side. All right, the inside says d of 2. So really what I want to do is 5 plus 2, working with my d function. So that's going to equal 7. So now I want to know, what is c of 7? So c of 7, I'm going to go ahead and substitute that in. 2 times 7 minus 10. which will give me 14 minus 10, which will give me 4. So what I have here now, if I kind of go back up to my original, I have negative 16 plus 4. And that is going to be equaling negative 12. All right, let's do another one of these. B of C of negative 3. I'm going to start on my inside, and I'm going to say C of negative 3. Okay, that means that I want to say 2 times negative 3 minus 10. I grabbed that C function from above. And I'm going to go ahead and simplify it. Negative 6 minus 10, well, that's going to give me negative 16. But now I want to know, what is B of negative 16? Okay, it's going to be a nice big number here, it looks like. So that's going to be negative x squared. Okay, so negative 16 squared. Okay, if I square negative 16, that's going to give me 256, and then I have a minus that I'm going to multiply it by. So my B of C of negative 3 is just going to give me negative 256. So I'm going to write it up here, negative 256. Now I want to work with my D of C of 1. All right, well, work on the inside first, C of 1. So I want to take my C function and say 2 times 1 minus 10. Which is going to be 2 minus 10, which is going to be negative 8. And then I want D of negative 8. So I'm going to say 5 plus negative 8. And that's going to give me negative 3. So on this side, it's just going to have minus and then my negative 3 value. So really what I'm going to be doing here is saying negative 256 plus 3, right? Which is going to equal to negative 253. All right, let's do some multiplication and division now. It works the same exact way. So let's do my multiplication over here first. I'm going to split these up. B of negative 2. Okay, B of negative 2, let's go ahead and say negative x squared. I want to substitute negative 2 in there. So negative 2 squared. That's going to give me a negative 4. And then I want to find C of negative 4. That's going to be 2 times negative 4 minus 10. So negative 8 minus 10, that's going to give me negative 18. So my top one's going to be negative 18. Okay, and then I want to know what is D of negative 10. All right, so let's take our 5 and let's go ahead and add negative 10. That's going to give me a negative 5. All right, I'm going to multiply negative 18 by negative 5, and that is going to be a positive 90. And the last one, we're going to do division. I'm just going to kind of break it up into my top and bottom here. So here's my top, and here's my bottom. So my top is going to be C of A of X. Okay, well, A of X is going to equal negative 4. So this piece right here is going to be negative 4. So I'm going to say C of negative 4. And that's going to be 2 times negative 4 minus 10. That's going to be negative 8 minus 10, which is going to be negative 18. All right, so my top, my numerator, is going to be negative 18. And my denominator, D of negative 3, I'm going to substitute negative 3 into that D function. And that's going to give me 2. So my denominator is going to be 2. I'm going to divide them to give me negative 9. Okay, and that is the end of my composite functions video. So feel free to go back and pause the video and try some on your own.